All right, good afternoon. Thank you for joining me. This is Sean Rogers here at Zyxel. One of the many hats that I wear is wireless product manager, and today we are talking about our new Wi-Fi 7 access point. As we go through today, feel free to ask questions. Use the Q&A box or button or whatever it is on your version of Zoom there to type in any questions you have. And depending on the question, I'll either answer it as we go or I'll save it for the end. So without any further ado, we're going to start by talking about Wi-Fi 7 in general, what it does for you, what sort of new features it has, and then we'll start talking about our new access point and how it fits in with that. So Wi-Fi 7 is the latest version of Wi-Fi that's out there. So this replaces Wi-Fi 6 or 802.11ax. This is 802.11be for the 802 numbering, or of course Wi-Fi 7. So the main things that we're going here with Wi-Fi 7 is just like every other flavor of Wi-Fi when it comes along is faster speeds. We're talking speeds in theory up to 46 gigabits per second. Top speed is going to be possible using Wi-Fi 7 technology. They've increased the QAM, which is how you encode data onto the radio waves. So Wi-Fi 6 added 1024-bit QAM, and now with Wi-Fi 7, it jumps up to 4096 QAM, which in reality gives us about a 20% increase in performance. Another way where we're getting our faster speeds is we've increased the channel width that we're using. So you might remember with 802.11a, b, and g, we used 20 megahertz channels. 11n introduced 40 megahertz channels, and then we jumped up to 160 megahertz channels with 802.11 AC Wave 2 and with Wi-Fi 6. And now with Wi-Fi 7, they're introducing 320 megahertz channels. So a big chunk of spectrum so you can send more data. They're adding a new technology here called MLO, and we'll talk a little bit more about it here in just another second. But it basically allows us to combine different connections together. And then also multi-AP coordination, the ability for access points to talk to other access points in the vicinity on the same network and coordinate how they're going to handle the clients and how they're going to divvy up the available airtime that's out there. So just a quick summary of, where things have been. Wi-Fi 5, aka 11n, launched back in 2013. Wi-Fi 6 was 2019. Wi-Fi 6E was 2021, and now Wi-Fi 7 is 2024. So you can see here, things have been really speeding up as the new technologies build on top of each other. The gap between new technologies has been shrinking. And you will notice I said for Wi-Fi 7 2024. And the reason for that is the Wi-Fi 7 standard has not been ratified yet. Everything that we're doing today is based on a draft that came out a year ago or so. And we're still waiting for the final version of Wi-Fi 7 to get ratified. So we're still based off of the draft. So I'll talk a little bit more about that here in a future slide. Some of the key differences here when you're looking at this is just the channel width going up, the encoding going up, and then another way we're getting to these faster speeds is we've increased the number of spatial streams a single access point or client can use. So with Wi-Fi 6, in theory, you could get up to 8 spatial streams. Zyxel never sold a product that supported more than 4 spatial streams at a time. With Wi-Fi 7, in theory, you can have access points and client devices that support up to 16 spatial streams at the same time. So that's how we are able to bump up the speed from just below 10 gigabits per second up to a theoretical maximum of 46 gigabits per second. So I just want to show here for the available spectrum we have here. So here is our 2.4 section of spectrum. There's around 60 megahertz of usable bandwidth that's there for you. We have our 5 gigahertz spectrum here. So that's 500 megahertz, but as we talked about in the Wi-Fi 101 presentations and stuff, a lot of this middle section of 5 gigahertz isn't going to be used by most of you because it requires what's called DFS. So DFS can cause increased disconnections, and that's a feature, not a bug. And also DFS isn't supported by a lot of consumer devices. So if you're building a network where people are bringing their own hardware in, you don't want to use DFS because there's a decent chunk of your users will not be able to connect to it. And then with Wi-Fi 6E, we added this 6 gigahertz spectrum. So one of the cool things with Wi-Fi 7 is Wi-Fi 7 allows you to use all 3 bands at the same time simultaneously, not just on an access point basis like with Wi-Fi 6E, but on a client basis. You can, in theory, have a client that's able to connect to all 3 at the same time. So now one of the key things here when it comes to Wi-Fi 7 is you're just now seeing products hitting the market. You saw consumer routers and some mesh solutions come out, I think back in July. A lot of stuff was announced early in the year or late last year, but just started hitting then. When it comes to business access points, I believe we are the first to actually ship a product. I know Ruckus and Ingenious are planning to ship something also this month. We started shipping end of October. So we beat them by a little bit here. But the key thing when it comes to any sort of new Wi-Fi technology is not how quick can you get an access point or router, it's how quick can you get a client device that works with Wi-Fi 7. So those of you that like iPhones, you may remember that with the iPhone 15 finally got around to adding Wi-Fi 6E support. Just with this new model with the 15. So that shows you how much of a delay there is because Wi-Fi 6E has been out for a little while, and they're just now getting around to supporting it. As far as I know, the only shipping client device currently that supports Wi-Fi 7 is Google's Pixel 8 series, which just launched recently. There should be laptops and some other stuff coming out here before the end of the year that support Wi-Fi 7, but it's going to be a while before it gets there. For instance, Fire TV sticks, Apple only just got around to adding 6E support on the 4K Fire Max 2 this summer. So, it's going to be a while before you see clients out there that support Wi-Fi 7. And also, like with other technologies like this, it's going to be a while before you see clients that support all the features that the access points and routers support. So it's something to keep in mind. At least as we sit today, there's not a lot of clients that can take advantage of Wi-Fi 7. So some of the other features here, I told you I was going to talk about this later, was MLO, multi-link operation. So traditionally, the way you have a multi-band access point, your typical 11AC or Wi-Fi 6 access point, you've got 2 radios, one operating on 2.4, one operating on 5 gigahertz. And generally, you connect to one or the other with your client device. You'll connect to 2.4 or 5, and that's it. So that's what we call single link operation. That is what Wi-Fi has been all the way up until Wi-Fi 7. So one of the new features with Wi-Fi 7 is multi-link operation, which in theory allows a client device to connect to multiple radios on your access point simultaneously. So your client device can be connected to 6, 5, and 2.4 all at the same time and can send data across all 3 of those. So the benefits of this, there's different ones. One of the things you can do is you can increase data rate. You can send different data across each of these connections and then have it aggregated at the other end. Another one here, it helps you reduce latency and increase reliability. And basically what you do is you send the same data over 2 or more of these connections. So that way, if there's RF interference, there's airtime utilization issues, whatever it happens to be that causes a packet to get dropped and need to be rebroadcast on one radio, well, that packet was also sent on a different radio. So you can just combine those together. You don't have to wait for a rebroadcast of those drop packets. You just grab them from one of the other streams that you're using and then combine them all together to one. So it might be a nice tool here for those of you doing latency sensitive stuff over Wi-Fi, in particular being able to do voice calls, which don't require a lot of bandwidth, but are really sensitive to drop packets and latency. So you'll be able to have better latency on those voice calls when you're using Wi-Fi 7. And then also just in general, you can avoid interference, right? You're sending data over all 3 of these. You can be using whichever one currently is providing the best signal for where you are in that building and what else is going on in the RF environment. Another one of the features we talked about before was with Wi-Fi 7 here. Whoops. I don't think that's the slide I wanted. My bad. That's the slide I want. There we go. So with Wi-Fi 7 here, Wi-Fi 6 added OFDMA allows us to chunk up the available airtime between different clients when you're doing multi-user MIMO into smaller segments than we could before with Wi-Fi 5 and earlier technologies. Wi-Fi 7 now allows coordination between those access points. So you can go in here and coordinate between your APs when you've got excuse me, let me try to phrase that better. When you've got APs in the same vicinity that are using the same channel, usually they are fighting with each other over the available bandwidth there. So with Wi-Fi 7, your APs are able to talk to each other and coordinate and divvy up the available bandwidth that's available between the two access points so you're not stepping on each other's toes. So you are reducing the overall available bandwidth, but you're doing it in a way that doesn't cause packet drops and loss and things like that. So it's a nice new technology for those dense deployments where you've got a lot of AAPs in the same area. Another cool technology when it comes to Wi-Fi 7 is multi-RU puncturing. So again, this has to dealing with interference in dense deployments. And what this does is basically, right, when you're using Wi-Fi 7, you can be using up to 320 megahertz channels, which are really big, right? There's one 320 megahertz channel and 5 gigahertz. So if you're using that, pretty much any other Wi-Fi device using 5 gigahertz in the area is going to be overlapping in what would traditionally cause interference. So with Wi-Fi 7, we have the ability basically to look and say, hey, wait a minute, there's another device using, say, it's a Wi-Fi 11 AC device. It's using a 40 megahertz channel. And we can intentionally basically take our 320 megahertz channel that we're using for Wi-Fi 7 and create a 40 megahertz hole in it, so it doesn't interfere with that other device, so that other device doesn't interfere with you. So you've reduced the overall bandwidth and speed you can get, but you're doing it in a way that doesn't cause packet drops or packet loss. So it's a much more stable, reliable connection by freeing up that space with this puncturing. Now, as I mentioned before, currently Wi-Fi 7 is based on a draft. The original draft came out in Q2 2021. So everything that's out there calling itself Wi-Fi 7 today is based off of this draft. The official release is currently estimated to be sometime at the end of the first half of next year. And on top of that, with Wi-Fi 7, there's also a plan for a second release that's going to be available in 2025. So you might remember with 11 AC, we had Wave 1 and Wave 2. We're seeing a similar thing here where we've got basically draft, Wave 1, release 1 in this case, and then Wave 2, release 2. So it remains to be seen, devices bought today, whether or not some of the new features that are added in release 1 and release 2 will be able to be added via software to the existing hardware. Based on past experience with 11AC and with 11N, a lot of those features probably cannot. So that's something to keep in mind. Some of these Wi-Fi 7 features that we're talking about, for instance, that multi-AP coordination, it doesn't exist today with the current draft. It's something that's coming later. I think multi-AP coordination is release 2. I could be wrong on that, but I think it's targeting release 2. So chances are hardware today will not be able to support that multi-AP coordination. You will need new hardware to do that. Now, having said that, the client devices are always going to be backwards compatible. So as we go forward, new Wi-Fi 7 clients, even if they're based on release 1 or release 2, will still be able to talk to and work with Wi-Fi 7 draft devices that you buy today. It's just some of those new features may not, are going to be missing, so you won't be able to take advantage of some of those advanced features that you may need new hardware to do. So it's not like your hardware, you have to throw it out. Anything you buy today will continue to work going forward with new Wi-Fi 7 clients. And so let's go ahead and start talking about now our product. Our new AP is the WBE660S. So this has been available since the end of October through distribution. Now our current supply is very limited. So in order to purchase this, you would just go to your normal distributor, And you will need to request that they drop ship it. We are not stocking this in distribution itself. We're keeping our stock in our Anaheim warehouse. So you will ask your distributor to drop ship it. Some distributors and sales guys will just do that automatically when you ask for it. Some of the sales guys, depending on who you get, you may need to push them a bit and tell them that they can do it. So it just depends who your distributor is and who your sales guy is, but it is available for you to purchase today. We will be getting more stock in the beginning of December, and then we'll be getting a bunch of stock early next year. So things will free up. We aren't currently doing any NFRs, but we will start doing NFRs once we get some more stock in for those of you that don't want to buy it and just want to test it out. So this is our guy here, the WBE660S. For short, we just refer to it as the WBE660S. Since our previous APs, the WAC and WAX, it was really easy to say WAC or WAX. It's really hard to pronounce WBE. So Weeb would be the short version when you're talking to our sales guys. Just mention the Weeb. This is our first Wi-Fi 7 access point. There will be a second lower end Wi-Fi 7 access point available early next year. That's coming. And we'll talk about it when it actually arrives. For right now, this is available for you today. This is Wi-Fi 7 based. It's 3 radios. All 3 radios work at the same time, and it provides speeds up to 22 gigabits per second. And of course, that's your traditional Wi-Fi speed measurement, where we're measuring not only the data you're sending, but also all the overhead data that goes between the access point and client to make Wi-Fi work. So realistically, you're going to see about half that, or somewhere around 10 gigabits per second. It'd be realistic to see on a speed test or something like that. So here's the hardware itself. All 4 radios support 4x4 spatial streams, so 4 transmit streams, 4 receive streams. Like our other business class APs, we have our cellular interference filters built in to make sure that if you're deploying this in a building that uses a DAS system to rebroadcast cellular signals in the building, that it doesn't interfere with your Wi-Fi connection. It has our smart antenna technology built in on it. We're using a Qualcomm quad-core CPU that's based on Wi-Fi 7 here, specifically purpose-built for it. This is a Nebula Flex Pro product, so you can manage it standalone. You can manage it in the Nebula Cloud. And at some point in the future, you will also be able to manage it with a local controller. I don't believe support has been added yet on our USGs to manage this. So it's got our traditional RF first build philosophy built into this. So just like our other APs, you'll see a lot more shielding on the board itself compared to some of our competitors' products. Now you will notice there is no big metal heat sink behind the board. And that's something I often talk about in our other presentations, that we have this big heat sink to pull heat off the board, because heat fatigue is one of the leading causes of failure on a solid state device like this. So why do we not have our metal heat shield back there anymore? The answer to that is because the rear of the housing is now our heat shield. So our housing here has got big giant fins on it because this gets hot, right? We've got 3 radios we have to power. We've got a CPE that's going to have to process over 10 gigabits of data per second. We have a 10 gig Ethernet port in there. So it uses a lot of horsepower, it uses a lot of electricity. And because of that, it gets hot. So instead of putting a heat shield in there, we have made the back of the case the heat shield itself. And another photo here, you'll see what I'm talking about here. But just like our other devices here, we have our smart antennas mounted not on the main PCBA, but on their own separate isolated board to create that better isolation between the board and the antennas for the better signal to noise ratio for you. As mentioned, 10 gig uplink port. That's going to be where your backhaul is. So your Ethernet connection doesn't become the bottleneck for your wireless users. In theory, it does have a second 1 gig port, so you can daisy chain it to another device. We have Bluetooth BLE built in. So Bluetooth low energy for IoT applications, that is built in on this device here. Here's the back of the device. As you can see here, it's a pretty heavy duty back of the shell here. It has the fins here, which for heat dissipation. It also works here for increasing the shielding of the board from interference. When it comes to power, because this is a powerful device, if you're using PoE, it needs to be 802.3 BT PoE, otherwise referred to as PoE++. We sell some switches that support that. We sell power injectors that support that. Alternately, if you don't want to use PoE, you can use USB-C to power this. It requires a USB charge adapter like you would use to charge your phone or something like that that supports PD, power delivery of at least 45 watts. So those are your two options for powering this: USB-C, using standard PoE supply that, or excuse me, power supply that you would provide yourself. We don't sell one ourselves. Or 802.3 BT PoE. And we do have a new mounting bracket, although it's basically similar to our current mounting bracket. It's just modified for the new case bottom here. And it's basically designed to allow you to mount this to a drop ceiling, to mount this to a wall, to a standard ceiling, to junction boxes, outlet boxes, etc. And just like all of our other Nebula device or other access points, this does work with Nebula. That is our primary recommendation, is to use Nebula to set up and manage your wireless network. It is our free cloud-hosted management solution. So a question that comes in here is, where would you want to use Wi-Fi 7? It's expensive, not only the APs itself, but it's going to require probably that you want to upgrade your switches as well to support at least multi-gig, if not full 10 gig. And you may need some additional switches to provide the power that you need for these deployments. So basically the area where this shines is similar to our Wi-Fi 6E access points. It's specifically going to be really good for high density locations, whether that means lots of access points in an area, such as some office buildings or a condo or something like that, but also in areas where you just have a lot of users crammed into the same space, large conference rooms, expo centers, things like that, or where you're going to be able to take advantage of the extra bandwidth and the extra capabilities that are part of Wi-Fi 7. Other areas where you may want to use this is just like with Wi-Fi 6E. You may want to use these for a mesh type solution using that 6 gigahertz, right? Because right now there's not a lot out there that supports 6 gigahertz. So use that 6 gigahertz radio as your backhaul radio when you create a mesh. So you've got a high speed, pretty much interference-free radio to link your APs together, and then your clients would still connect on 2.4 or 5, which is what most of them support today. So it allows you to have a lot faster and more reliable mesh type network if you're doing that. And then also anywhere where you need a ton of bandwidth, such as streaming uncompressed video. Wi-Fi 7 has the bandwidth to be able to support that. And then just technology-wise, I wanted to take a few slides here to talk about smart antenna. I know most of you watching today have already heard about smart antenna from some of our other presentations, so I'll just talk about it really quickly. Smart antenna is a technology we have. It's similar to Ruckus's BeamFlex Plus technology that's designed to reduce interference, increase capacity, et cetera, et cetera. So while Wi-Fi 7 has been designed to handle a lot of these things by themselves with the new technology, smart antenna still stacks on top of that to provide additional benefits for you out in the real world, especially since a lot of those Wi-Fi 7 features are going to require Wi-Fi 7 clients. So until those Wi-Fi 7 clients come along, some of those new features can't be used. So basically, smart antenna, instead of doing like most access points where they've got a fixed antenna coverage pattern, instead with smart antenna, we use an algorithm and a special type of antenna design that allows us to go through hundreds of different antenna configurations for each Wi-Fi client that you have. And our algorithm optimizes the signal based on where the client is in relationship to that access point. But our algorithm also looks at other sources of RF interference, whether those be access points being run by a different network, or whether those are industrial equipment that's producing RF interference. And then we optimize the antenna pattern to sort of ignore that RF interference. So that's it as far as today's presentation goes. If you have any questions, start sending those in the question and answer interface there in Zoom. I do just want to let you know, most of our webinars are recorded and we do post them to our YouTube channel, which is youtube.com/Zyxel America channel. So if you didn't get to sit through all of today's webinar, or you want to share it with somebody, or you want to catch one that you missed in the past, you will usually find those on our YouTube channel within 24 to 48 hours of the webinar itself. And then always you can connect with us here on LinkedIn at Zyxel US channel. So far, no questions. So I'll stick around for a few more minutes in case you're working on something. But thank you for joining. Thank you for turning up. We do webinars on Tuesdays and Thursdays. Generally, Tuesdays are a little bit more tech oriented, where Thursdays are more high level overview type presentations. So check out those. I put them on. Try and Marcus put them on. So check those out. So Keith has a question, and I'm not sure I understand the question. Well, I'll go ahead and read it out here. Does Wi-Fi 6 operate faster with greater signaling? So I'm not sure what greater signaling is referring to when it comes to Wi-Fi. So I'll stick around for a second. Maybe you want to explain that. For whatever reason, I'm not catching what you're asking about there. So I will talk here just in general here, 6 gigahertz or Wi-Fi 6E. Okay, so he's saying meaning distance from AP. So unfortunately, no. What you're running into is just physics. Basically, as RF frequency goes up, the easier it is, or excuse me, how should I put that? The more easily the signal is attenuated or absorbed by things in the environment. So walls, people, even the air itself, particularly humid air, will absorb RF. So as that frequency goes up, it gets absorbed more, which means the overall range is less. So whether we're talking Wi-Fi 6E or we're talking Wi-Fi 7, in general, you're going to have lower range with a 6 gigahertz signal than you would with a 5 gigahertz signal. And a 5 gigahertz signal is going to have worse range than a 2.4 gigahertz signal. So that's kind of the trade-off. You've got a lot more bandwidth. You don't have to worry about interference when you're going up to 6 gigahertz. You've got all this spectrum to play with, but the range is going to be less. So if you want, 6 gigahertz coverage equivalent to what you're getting today with 5 gigahertz, you are going to have to put more access points into that same area to provide that coverage. Well, so this is from Michael. Michael is asking, will 6E clients interfere with 7 clients on 6 gigahertz? And the answer is no. It's just like Wi-Fi today, when you've got 11 AC clients, you've got Wi-Fi 6 clients all connecting to the same radio. They don't really interfere with each other. They all play nicely with each other. But certain features, right, you have to have matching technology to support those features, and some of those features, operate less efficiently when there are legacy clients connected. In general, I wouldn't worry too much about it. I don't think it's a real problem. Especially with the speeds we are talking about today with Wi-Fi 6 and Wi-Fi 7, some of the little bit of slowdown that you're going to see when you're in a mixed environment probably aren't going to be an issue between 6 and 7, or not going to be something that you're actually going to be able to see yourself with your own eyes. And while we wait here, let's see. Oh, Chris sent in another question. Is the new Wi-Fi 7 AP going to be standalone or Nebula controlled? So it is Nebula Flex Pro, Chris. So it can be standalone. It can be managed with Nebula today. And at some point in the future, it can also be managed with our local controller. I'm not sure exactly when that's coming out. So it's just like any of our other APs. It supports all 3 modes, 2 of them today. Keith is asking, are there any settings for smart antenna, or is it plug and play? It is entirely plug and play. If you buy one of our access points that has smart antenna, it just does smart antenna things as soon as you plug it in. There's no adjustments, there's no settings or tweaks in there. It just is there for you. It's all basically self-contained, and it just does its job. So that allows it to react super fast. It's one of the reasons why, you can use it with mobile clients as clients move around, where some other similar technologies really require the clients to be still. smart antenna is able to handle those mobile clients just because of how optimized it is. And it's all sort of basically just baked into the smart antenna hardware itself. And while we wait to see if a few more pop in, I will draw your attention to our user forums, forum.zyxel.com. So those are user forums. They were created to give you a place to talk to other Zyxel users or resellers. Unlike a lot of our competition, we do have our R&D and product management team monitoring the forums. They do often pop in there to answer questions. But if you have feature requests and things like that, it's a great place to post those because obviously we're always getting requests from people for new features, and we have a hard time deciding what gets priority over what. So if you post something that's a good idea and a bunch of other people on the forum chime in and say, yes, I want that too, that dramatically increases the likelihood that we'll add that feature in the future and helps us know to prioritize that feature. It's also usually the first place where we post release notes, security bulletins, things like that. Okay, I'm not seeing any more questions, so I'm going to go ahead and end today's webinar. If you do have a question, if you're one of our resellers, just reach out to your salesperson, Andy, David, or Jacob. They can answer that question. Also, my email is up there on the screen, seanr@zyxel.com, with Sean spelled SHAWN. You can always just email me directly or email your salesperson, and they'll either get you the answer or can put you in touch with me. So thank you for turning up today, guys. Hope to see you at one of our future webinars.